So today we're continuing with chapter 9. Today we are going to be focusing on absolute value equations. And this is going to get us ready for our next lesson. The next time I see you guys, which will be solving absolute value inequalities. So we're going to practice solving absolute value equations today to get us ready for our next lesson. The next time I see you guys, absolute value inequalities. Okay, so let's get started. Absolute value equations. And remember these notes, you guys are going to be sending in to me in Google Classroom. So don't forget to do that for our classwork assignment. Okay, so we're going to start out with the definition of absolute value. Absolute value is how far a number is from zero. So absolute value is how far a number is from zero. So again, absolute value is how far a number is from zero. It is always going to be a positive number. It is always going to be positive because it's distance. It's how far you are, again, from zero. So as an example, let's just understand what an absolute value of a number is. So let's say we have the absolute value of 3. The absolute value of 3 is asking how far from zero are we? We are 3 away from zero. The absolute value of a negative 3 is also 3, because negative 3 is also 3 away from zero. So sometimes people mistakenly think absolute value means make opposite. It should always be giving you a positive back. Just kind of an example on the number line. Here's 0. I want to see how far 3 is from 0. So we've got 0, 1, 2, 3. How far is this? Well, this is 3 away. And that's why that is 3. Well, going the other direction, negative 1, negative 2, negative 3, how far is that from 0? It is also 3 away. So that's why this is also equal to 3. So again, it's how far you are from 0, and it should always be a positive. Okay, so now let's try solving. So in order to solve, this is the steps I would take. So how to solve absolute value equations. So how to solve absolute value equations. Okay, so these are the steps. First step, isolate the absolute value. So that means get the absolute value by itself. Isolate, absolute value. Okay, that's your first step. Second step, check the sign of the number on the other side of the equal. Check the sign of the number. So check the sign of the number on the other side of the equal. So basically, this is what you're going to do. You're going to check to see if it's a positive sign or a negative sign. So if it is a positive, on the other side of the equal, we're going to write two equations and solve. And those will be your two answers. If it is a negative, then there's no solution. And again, why is there no solution? Because your absolute value is always going to be equal to a positive. It will never be equal to a negative. Okay, so let's get started. I'm going to start us off with just kind of a basic one, and then we're going to progress from there. So absolute value of x equals 10. Now remember, there's two different things that could be going in here. The absolute value of 10 is equal to 10, and the absolute value of negative 10 is equal to 10. And again, the first thing I said to do up here is to isolate the absolute value. That means to have your absolute value by itself. It is. Second thing to do is to check the sign on the other side. Check to see if it's positive or negative. Now, this is a positive. Okay. This is positive. So since this is a positive, you're going to write your two equations. The two equations you're going to do is the following. You're going to take what's inside the absolute value, and you're going to set it equal to the 10. The second equation, you're going to, again, take what's inside the absolute value, x, but this time you're going to set it equal to negative 10, because again, you could have had a 10 that this was equal to, or a negative 10. Now, in this case, once you do that, you actually have your answers. Your two answers are going to be x is equal to 10, and x is equal to negative 10, and those are your two answers. So now let's take it one step further. So let's try one a little bit more complicated. So let's say, for example, we have the absolute value of x minus 3 is equal to 10. Again, you want to make sure that your absolute value is isolated. It is. And then you want to check the sign over here. You want to check to see the sign. And again, this is positive. So you're going to write your two equations. First equation, you're going to take again what's inside the absolute value, x minus 3, and you're going to set equal to 10. The second equation, you're again going to take what's inside the absolute value, x minus 3, and this time you're going to set equal to negative 10. And you're going to work these two equations out. So for the first one, I'll just push it up a little bit more. I'm going to add 3 to both sides. So when I add 3 here and I add 3 here, I get x on this side equals 13. That's going to be one of my two answers. On the other side, again, I'm going to add 3, and when I add 3 to both sides, I'm going to get x is equal to negative 7. And that's my second answer. So again, I have x equal 13 as one answer, and x equal negative 7 as the other answer. So if I put 13 in here, 13 minus 3 is 10, and the absolute value of 10 is 10. If I put a negative 7 in here, negative 7 minus 3 is a negative 10, and the absolute value of negative 10 is also 10. That's why we're getting two answers. Okay, so let's move on and try another one. So let's say our next example is absolute value of 3x minus 5 is equal to 6. Again, you want to make sure your absolute value is isolated. It is. If it is isolated, you want to look over here to see what type of number this is, and this is a positive. So if it's a positive, you're going to write your two equations. So your first equation is going to be 3x minus 5, because that's what's inside my absolute value. I never make anything change this. It's going to stay, is equal to 6. My second equation, again, I'm going to take what's inside my absolute value, 3x minus 5. And this time, that 3x minus 5 could have been a negative 6. and we work these two out. So I'm going to add 5 to both sides. When I do, I end up with 3x is equal to 11. I divide both sides by 3. I get x is equal to 11/3. Over here on the other side, again, I'm going to add 5 to both sides. When I do, I get 3x is equal to -1. I divide both sides by 3, so I get x is equal to -1/3. And those are our two answers. So I should always be getting two answers if my absolute value is equal to a positive. The only time I would not get two answers is when my absolute value is equal to 0. And I'll go through an example like that. I'm going to get one answer. Or if my absolute value is equal to a negative, then I'm going to get no solution. Okay, so let's try one more like this. Absolute value of 2x plus 3 is equal to 15. Again, I'm looking to see, is my absolute value isolated? It is. It's all by itself over here. On this side, this is a positive number. So again, this is positive. And since that is positive, that means I'm going to write my two equations. So my first equation is going to be 2x plus 3 is equal to 15. My second equation, again, I'm going to take this 2x plus 3, and this time set it equal to a -15. And I'm going to solve this. So I'm going to -3, -3. And when I do, I get 2x is equal to 12. I'm going to divide both sides by 2. When I divide by 2, I get x is equal to 6. And that's my answer, one answer. On the other side, I'm going to also -3 from both sides. And when I do, I get 2x is equal to a -18. I'm going to divide both sides by 2, and I get x is equal to -9. And these are my two answers. And again, if I was to put 6 in here, 2 times 6 is 12. 12 plus 3 is 15. And the absolute value of 15 is 15. If I put -9 in here, 2 times -9 is a -18. And -18 plus 3 is a -15. And the absolute value of a -15, 15. Again, two answers. So now, let me give you the following. And this is one that has absolute value of 2x minus 4 is equal to a -36. So again, always make sure your absolute value is isolated. It is. Next thing I do is I look to see the number on the other side. And let me just switch colors here. Because over here, I want you to notice that this one is negative. And an absolute value can never equal a negative. Absolute value can never equal a negative. So what does that mean? It means my answer is no solution. Okay, or you can write it like that, whichever way you prefer. Okay, so no solution. Okay, so far I've gone through ones where you get two answers because we are setting it because it's equal to a positive and we write two equations and solve. I did one where it's equal to a negative, and that is no solution. Now let me do one that's equal to 0. So for example, let's say we have the absolute value of 7x minus 3 is equal to 0. Again, your absolute value is isolated. Looking here on the other side to see what I have, this is not negative. We call it a non-negative. So it's not negative, okay, or positive really. So in this case, I'm actually going to get one answer. The reason being is when I work this out, I get 7x minus 3 equals 0. That would be my first equation. And then when I go to start doing my second equation, I'm going to have 7x minus 3. And then I can't make this negative because when I take a negative times 0, I still get 0. That's why I'm going to get one answer. Okay? You don't need to write negative 0. So now I'm going to add 3. I'm going to add 3. And I get 7x is equal to 3. So x is equal to 3/7. And so in this case, I only ended up with one answer. And that's always going to be the situation when I have a 0 on the side. And again, if it was a positive number, non-negative, but a positive number, I'm going to end up with writing two equations. I get two answers. If it was equal to a negative, like up here, I end up getting one answer. So again, when it was equal to a positive, I write my two equations, I get two answers. When it's equal to a negative, I have no solution because there's nothing that can make that true. When it's equal to 0, I'm going to get one answer because 0 is 0. It's not positive, it's not negative. It's non-negative. Okay, so now the next one I'm going to do is going to take it up a step. So far, all of ours have been where this absolute value is isolated. Now I'm going to do one where that's not the case. Okay, so for this example, I'm going to have -8 minus 2 times the absolute value of 5x minus 7 equals a -14. So a couple things to pay attention to here. You might look over here and go, oh, this is equal to a negative, so this is no solution. But you don't want to do that until you isolate. You need to isolate. So when I say isolate my absolute value, I am talking about this absolute value right here. I need to get that absolute value by itself. I don't want this -2 timesing with it. I don't want this -8 subtracting from it. So I need to isolate it. So isolate absolute value. I'm going to abbreviate that. Isolate absolute value. Now, when you do that, you always want to first get rid of any adding or subtracting that's outside of your absolute value. Okay, so adding or subtracting. So I'm talking about this. This is multiplying. It's multiplying with this absolute value. So that my first would be to get rid of this -8. My second is to get rid of any multiplying or dividing. Okay, so now that would be talking about getting rid of this -2 that's multiplying. Okay, so first I need to isolate this. And again, the first thing I'm going to do is I'm going to add 8. I'm going to add 8 to get rid of my adding or any subtraction, depending on the situation, that is going on outside your absolute value. Now you want to be careful. This is a -2 you want to bring down times the absolute value of 5x minus 7 equals a -6. So again, I got rid of any add subtract that's happening outside. Now I'm going to get rid of any multiply or divide because again, I'm trying to get this isolated. Okay, I want to get that by itself. So now I'm going to divide this side by -2, divide this side by -2. So again, at first glance, this is a negative over here, but now that I'm dividing by a negative, the negative divided by a negative is a positive. So don't assume because you have a negative here that it's going to be negative and it's going to be no solution unless your absolute value is isolated. Okay, so now I'm going to get the absolute value of 5x minus 7 is equal to 3. So now it's isolated. Now I can check and see the sign. So again, at first glance, looked like it was a negative here, but after I cleaned it up, I end up with a positive. So now this is like those first problems that I was doing. I'm going to write my two equations. 5x minus 7 equals 3. My second equation, 5x minus 7 equals negative 3. And now I'm going to solve these. So I'm going to add 7 to this side and 7 to this side. And I end up with 5x is equal to 10. I'm going to divide both sides by 5. And I get x is equal to 2. Over here, I'm going to add 7 to both sides. And when I add 7 to both sides, I get 5x is equal to 4. I'm going to divide both sides by 5, and I get x is equal to 4/5. And these are my two answers. X equal 2 and x equal 4/5. So this one's a little bit more complicated. You're not going to see one this difficult on tonight's homework, but this is important that you understand, especially going into integrated 2 and 3 in the future. So again, you always want to get your absolute value isolated first. You don't want to start writing your two equations before. You don't want to decide if it's going to be a situation that's no solution until you get your absolute value isolated. You want to get rid of any adding or subtracting that's going on outside. Then you want to get rid of any multiplication or division. Once you get it isolated, then you decide if this is a positive or a negative. If it's a positive, you write your two equations. If it had been a negative, then that would have been no solution. Okay, now this last part is something that's a little bit more complicated. And this is really geared towards those of us who are going to possibly going into integrated 2 math analysis especially, but it's really good for all of the students in integrated 2 to understand, but definitely if you're going to be thinking about going in integrated 2 math analysis. So I'm going to draw a little line just to kind of split this up. And now what I'm going to do is I'm going to go over one where you have an x outside. So if you have an x outside of the absolute value, I'm going to abbreviate absolute value, you are going to have to do an extra step. So you need to do the following, okay? First, isolate your absolute value, just like we did in the previous steps. Now, usually the second step is to decide, I'm going to move this down for 1 second and I'll put it back up, is to decide, once it's isolated, if this is positive or negative. If it's positive, we write our two solutions. When it was a negative, we had no solution. In this case, we're going to have an x on this side. We can't decide if it's positive or negative. It depends on what x is. So we are going to write our two equations. Okay, write your two equations and solve them. Okay, now here's where the extra step comes in. You solve them, but again, we don't know if that x on the other side was going to be a positive or a negative. And when I say x, I really mean the whole side. So what we need to do is you must check your answers. In your equation, and I'm going to say in your your equation where you isolated your absolute value. Okay, so you must check your answers in your equation where you isolated your absolute value. I would not do it in the original problem. That's not going to be helpful. You want to do it in the one where you isolated your absolute value. Now, what you're going to be doing is to see if that x makes that side on the other side of your absolute value positive or negative. So if you get a positive result on other side of equal, then that is a solution. Okay, you found a solution. Whatever that X is, it worked. It gave a positive on the other side. If you got, or if you get a negative result, on other side of equal, space that out a little more, sorry. On other side of equal, then it is not a solution. I don't want to say no solution because you're going to have two different values you're trying. One of them may work, the other one may not. Both of them can work, or sometimes none of them work. So we're going to try an example. So I'm actually going to flip my page. Okay, so let's say for our example, we have absolute value of 2x plus 5 minus 4 equals 3x. So again, what you want to notice here is you have x outside of absolute value. You have x outside of your absolute value, okay? Now, I have an x here, but I'm really concerned that I have an x there. That's where the problem is. So my first step is still the same step I was doing before. Isolate absolute value. So I'm going to add 4 to both sides. Okay, on this side, I have the absolute value of 2x plus 5. So it's isolated, equals 3x plus 4. Now, when I said you would check where it's isolated, the equation, really all you need to check is this. You want to decide if this is going to be positive or if this is going to be negative. So this is where you're going to check, okay, check answers. Check answers here. That's where you're going to check your answers. So again, this could be a positive. Let's say my x was 10, 30 plus 4 would be 34. That would be positive. Let's say my x was a negative 10. That would give me a negative 30 plus 4, which is a negative 26. That would be negative. So we need to check because we don't know if this is positive or negative. Okay, so now I'm going to write my two equations. 2x plus 5 equals, and I'm going to take this, 3x plus 4. My second equation, again, I'm going to take my 2x plus 5, but this time it's going to equal the opposite of this, which means I'm going to make everything opposite. It's going to be a negative 3x minus 4. And I'm going to solve these. I like to deal with my x's first. So I'm going to minus 2x. I'm going to minus 2x. And on this side, I'm going to get 5 equals x plus 4. I'm going to minus 4 from both sides. And I'm going to get 1 is equal to x. So I get x equals 1. Possibly, I'm going to check it here in a sec. Over here, I'm going to solve this one. Again, I'm going to deal with my x's. I'm going to add 3x. I like to have positive x's if possible. And so I'm going to get 5x plus 5 equals, those cancel out, negative 4. I'm going to then minus 5 from both sides. And I end up with 5x equals negative 9. Divide both sides, and I get a negative 9/5. Now, both of these answers might work. One of them, none of them. I need to take both of these answers, and I'm going to plug them here. I want to see here. This is where I'm going to check answers. And I'm checking them on their sign. What type of sign am I going to get back? Will it make it positive? Then that would be an answer. Will it make it negative? Well, then that won't be an answer. And you can't always rely on these signs here. You actually have to work it out because sometimes a negative might actually give you a positive back and vice versa. So I am going to check, okay, check 1. So I'm putting it right in here. That's all I care about. I don't need to put it in the whole rest of the problem. As long as I did the rest of my math right, I just want to decide if this is positive or negative. So I put that in here. I get 3 plus 4, which is 7. And so this is positive. Okay, so since this is positive, okay, since this is positive, that means this is going to be an answer. Now, this one could also work. We have to check. So I'm going to check, and I'm putting in a negative 9/5 into this. So I'm going to go 3 times negative 9/5 plus 4. I'm going to be putting this in my calculator. Those of us who got a Chromebook from school actually should have on your toolbar a TI-84 calculator at the bottom. So you might want to check that out. So again, I'm going to put this in my calculator. 3 times, and if I want to enter in fractions on this, remember, I can do alpha and y equal, and then I get fractions. Number 1 is fraction, and I'm going to be putting in a negative 9/5. Negatives down at the bottom, so make sure you put negative, not a minus, negative 9/5, and then plus 4. I put it in my calculator, and it gives me a negative 7/5. Okay, I'm not concerned with you doing that math in your head. Just put it in your calculator. And what we care about, is it positive or is it negative? And this one is negative. Let's change colors here. Let's see. So this is negative. So since that's negative, that means it made this right here negative. So that would not have been a solution. This is my only answer. This one is not. I'm going to go through one more like this. And again, these are a little bit more difficult. This is a little step up from the rest of the problems. Most of the problems you're going to see are like the first ones we did. Okay. Okay, so next problem, last problem. For this one, 5 times the absolute value of 6 minus 5x is equal to 15x minus 35. Again, we have x outside. So that means it's going to be one of these ones that I have to check. Okay. First thing again, isolate. Isolate absolute value. Always your first step. Now, in this case, to isolate this absolute value, I'm going to divide this side by 5. And on this side, I'm going to divide each of them separately by 5. I think that math's a little easier, makes it a little nicer for us. Those are going to cancel out, and I have the absolute value of 6 minus 5x equals, here, I divide that, I get a 3x. Divide here, I get a minus 7. So I've isolated it. This right here is where I'm going to check answers. Check answers here. Because I do not know if this is positive. I do not know if this is negative. I need to know what my x is. So we're going to work it out. We're going to write our 2 problems, our 2 equations. 6 minus 5x equals 3x minus 7. My second equation again, still 6 minus 5x, but this time I'm going to make this side opposite. So I get a negative 3x plus 7. I make both of these opposite of what they were. Going to solve. Again, I like to do x's first, so I'm going to add 5x to both sides. I'm going to get 6 is equal to 8x minus 7. I'm going to add 7 to both sides. And I'm going to get 13 is equal to 8x. I'm going to divide both sides by 3. So I get, I'm sorry, not by 3, by 8. So I get 13 over 8. And that's a possible answer. I'm going to come over here I'm going to go through the same process again. I have x's. Adding 5x will be easier. Give me a positive number. I get 6 is equal to 2x plus 7. I'm going to minus 7 from both sides. And I get negative 1 is equal to 2x. Divide by 2, I get a negative 1/2 is equal to x. So these are the two numbers I'm going to check. And again, I'm checking to see the sign of this. So that's where I'm going to check answers. Okay, so I'm going to be putting in a 13/8 into here. So I'm going to check 13/8. And when I put 13/8 in, let me move this up a little bit. When I put 13/8 in, I get 3, again, I'm putting it right into this, times 13/8 minus 7. Put that in my calculator. So I'm going to go 3 times, and to get my fraction, I can do alpha y equal. Okay, again, the alpha y equal, and that's number 1. And I'm going to type in 13/8 minus 7, and I end up getting a negative 17/8. So this is equal to a negative 17/8. So I started with this being a positive, but I don't care if this is positive or not. I care about this. And when I put in 13/8, I actually end up getting a negative back. So that is a negative. So this one is not going to be an answer. Okay. So now I'm going to come over and check this one. So I'm going to check a negative 1/2. So I'm going to put that in here. 3 times a negative 1/2 minus 7. Now you might notice that I have, this is going to become a negative minus a 7. I should be getting a negative number, but let's just get the value of it. Okay. So let me just come up here. Whoops. Snag this. And I'm going to change this to a negative 1/2. And I get a negative 17/2. So this is equal to a negative 17/2. So again, this one happened to be negative also. So that means this is not a solution. So my final answer, no solution. So you could have both of them work. I didn't give you an example like that, but it happens. You could have one of them that works, like the one above, or none of them. Okay, so then I'll see you next class, and we'll be doing absolute value inequalities then.